Hello, welcome to Gustavus Adolphus College. My name is Dwight Stoll, and I'm an assistant professor of chemistry here in the department. In the following few moments, I'd like to give you a brief introduction to some of the key pieces of instrumentation here in the department. This instrument here is one of our key pieces of instrumentation. It's called a mass spectrometer, which can be coupled to a liquid chromatograph. This particular instrument is what we call a triple quadruple mass spectrometer, which is very useful for analysis of compounds at very low concentrations and in complex mixtures. This particular instrument is used primarily for student-faculty research, but we also use it in upper-level coursework as well. Some of the projects that have been supported by this particular instrument in the past couple of years and currently are a project which was focused on the development of new and faster methods for detection and quantitation of drugs of abuse in blood and urine samples, and that project was carried out in collaboration with some people at the Minnesota State Crime Lab in St. Paul. One of the projects we have ongoing right now with this instrument, one of the main ones, is a project that is a collaboration with some researchers at the University of St. Thomas and at the University of Minnesota, which is focused on measuring concentrations of antibiotics in the Minnesota River, very close to Gustavus, and then determining whether or not bacteria in the river in the same area exhibit any resistance to any of these antibiotics. As part of the Chemistry 380 course that I teach, which is called Instrumental Methods of Analysis, we also use this instrument heavily in that course, where students spend about a third of the semester designing and carrying out independent projects, and this particular instrument has been used heavily as part of those projects. In the past couple of years, some examples of projects that have involved this instrument have been the determination of atrazine in the water in a local lake, and also the determination of glutathione in bacterial cell extracts. Students can become involved in research projects at really any point in their career here at Gustavus and use this instrument as part of that work. I've had students in all 4 years of their experience here interact with this instrument in different ways. This instrument here is what we refer to as a gas chromatograph, this piece of the instrument, coupled to a mass spectrometer. This particular instrument, like our other mass spectrometer coupled to the liquid chromatograph, is really built for measurements of the mass of molecules, as well as giving us information about how molecules are put together. Our other instrument, the liquid chromatograph coupled with the mass spectrometer, is really well suited to the analysis of highly polar compounds, that is, highly water-soluble compounds. So with that instrument, we do a lot of work analyzing compounds in, for example, water samples directly, or blood, serum, highly aqueous samples. In the case of the gas chromatograph, this instrument is really well suited to the analysis of more volatile or non-polar compounds, things like fragrances and flavors, components of gasoline, and so on. This instrument is also used in both coursework and in research. Some examples of coursework include the second-year organic chemistry course, where students are asked to interpret data from this type of instrument. And for research projects, we use this instrument in a variety of ways. begin primarily looking at more volatile compounds. Another course where it's used quite frequently is in the environmental chemistry course, looking at specifically at pollutants in the environment and analyzing the samples of that kind. This instrument is what we refer to as an ICP-MS, or inductively coupled plasma mass spectrometer. Again, like our other two mass spectrometers, coupled to either liquid chromatography or gas chromatography, the ICP-MS provides us with information about the mass of, in this case, atoms, and particularly metal atoms, as they are detected. So this particular instrument is very well suited for the analysis of metals in a variety of different types of samples, whether they be environmental samples of lake water, ice cores, sediment cores, dirt, and components of different rocks. This is one of our most recent instrument acquisitions, funded by a research grant from the National Science Foundation. And this instrument is used heavily both in environmental chemistry courses and research, as well as geology coursework and research projects. One of the components of the kind of research grants that support the acquisition of this kind of instrument is there are funds set aside to support student research projects, and so it is very typical in a case like this to have 2 or 3 summer research positions open to students in a given summer for an instrument like this. And those kinds of opportunities are open mostly to students in their between their sophomore and junior and senior years. This instrument here is our NMR, or Nuclear Magnetic Resonance Spectrometer. This instrument is primarily used for characterization of organic compounds and is a key component of coursework in organic chemistry here in particular. This particular instrument actually will be replaced in the spring of 2012 with a new 400 megahertz instrument that will be funded as part of a grant, again, from the National Science Foundation. Some of the new, one of the important new features of this instrument will be the installation of an autosampler and web-based software that will allow students to access their data really from anywhere and control the instrument to analyze their samples really around the clock. Also in this particular room are located Fourier Transfrom IR spectrometers, which are also used in both research and coursework for characterization primarily of organic compounds. In these few minutes, I've highlighted some of the key pieces of instrumentation here in the chemistry department, but this certainly is not an exhaustive list of all of our instrumentation. If you have any questions at any time about instrumentation in the chemistry department here at Gustavus, please send me an email at dstol@gustavus.edu. That's dstol